requirements, which if you're not really up on things, you might think it's a boring topic. But trust me, your life will be ruled by requirements. So if we can have a little discussion today, if we can spend a little bit of time talking about requirements, and if I can show you some of the secrets, some of the insights to requirements and how you can become a master of requirements, this is the kind of stuff that will last you your entire career. Lots of things change, lots of things, stuff like that. This is something that you can use for the entire, I'm sorry, how long was your career?
45 years.
45 years. That's how good this information is. It might be just something to casually pay attention to. Whatever. I don't know. It's your call on this one. So quick question. So what is requirements? What is a requirement specification? It's a requirement specification identifies those requirements that a design must satisfy in order for it to be successful. Which actually sort of makes sense, right? Hey, I'd like you to create a design for me. It's a fabulous thing for somebody to say to you, right? But is anybody ever actually going to say that to you? No. What are they going to do instead? They're going to show up and give you what? A check. No, they're not going to give you a check. They're going to give you a requirement specification, right? They're going to say, here, make this, or create a design that does this. I mean, people don't really tell you to do something, and the reason is because it would take too long. I would like to have a box that does this, that draws this power, that uses these chips, and people use it. I'm not going to stand there and tell you that. I'm going to make sure that it's written down, that it's been reviewed by really smart people to make sure that nothing was forgotten, and then I'm going to hand it to you and say, go design this. So all of a sudden this becomes sort of the language that we talk about designs in. That sort of starts to make it a little bit more interesting. It needs to be a complete vision of the design goals. So you can't have half of the requirements and expect to make a correct design, right? You have to have the whole shoot and match. Otherwise, you're going to end up designing half a car, which is fantastic, but it's really not going to be of any use to anybody. It needs to identify all the important requirements. So here's my story about learning how important requirements are. So once upon a time, this would be probably the early 90s, I was very active in a standards body forum called the ATM Forum. And it was a group of companies that had gotten together that were working to define the standards for the ATM protocol when it had first come out. So man, everybody and their mother's uncle was there. So the way you work, if you're part of a standards body format, is that they break it up into subgroups. So there are lots and lots of subgroups, and each subgroup focuses on some particular area. The area that I was working in had a lot of people, had a lot of stuff going on. I, for some unknown reason, decided that I wanted to be chairman of my little subgroup. I wanted to rule the world. I want to be in charge, tell them what to do. Because I was smarter than everybody else, so clearly they should listen to me. I mean, come on, really, okay? So anyway, so I did all the right things. I ran around and I talked to everybody and said, hey, we're getting ready to vote for the chairman, and I can count on your vote, right? And everybody said, oh, you're good stuff. Yeah, that's not a problem whatsoever. And then it came time to vote, and I got my clock cleaned. A guy from IBM just walked away with it. He became the chairman. And I was like, what just happened to me? And so I was talking to one of the guys who worked for the same company as me, who'd been in standards forever. And he took me aside. He said, hey, Jim, what's up? And I said, oh, we just had a vote for chairman of my little group. And I wanted to be chairman, but they voted for somebody else. And I'm sort of bumming about this. And he said, okay, grasshopper, let me explain something to you. You really don't want to be chairman. He said, because the chairman, although it sounds like they're in charge, he said the chairman really just runs the meeting, okay? And it seems like they're in charge, but they're not really in charge. He said, I've got a suggestion. He said, why don't you nominate yourself to become secretary? And I was like, wait a minute, secretary? I think I'm a little better than just being secretary for some standards group. Come on, be real. He said, look, you're missing the point here. He said, don't get hung up over secretary. You're not going to be getting coffee for anybody or doing anything something like that. He said, here's the scoop. Secretary basically keeps the notes for the meeting. He said, all these bright, smart people who come together for these standards bodies meetings and have all these big arguments about, oh, we should do this or this, should put a semicolon here or remove it, all that stuff. He said, when they leave the meeting, they can't remember what they talked about. He said the only way they're going to be able to remember what agreements were reached or what was discussed is by going back and reading the minutes from the meeting. And he said, guess who prepares the meeting minutes? He said, it's the secretary. So arguably, whatever the secretary puts in the meeting minutes is treated as what was discussed. Whatever the secretary puts in the meeting minutes says, oh, we agreed to this, is what everyone is going to go, oh, I guess that's what we agreed to, right? And they will go from there. He said the secretary is really the most important person in the whole shooting match. If you don't document it, it didn't happen. Or however you document it is how it actually turned out. I was like, oh. So I became secretary. It was truly the most powerful position in the entire organization, and it was great from there. So, look, I love the title of chairman because it sounds really impressive and stuff like that, but really it was the person who was in charge of documenting what the agreements were and what we were going to work on and stuff like that was actually truly the person that had the power. But fundamentally, I was doing the requirements for the standards body, and I had not realized that. So, learn from my experience and understand whoever takes the notes is in charge of what's going on. And that's effectively what the requirements are. When you create requirements, when you create a requirement specification, one of the most important things is that it has to leave flexibility. So in other words, really a requirement specification has to document what something's supposed to do, which means it's not supposed to talk about what. It's going to say what it does. It's not going to talk about how it does it. That's exactly right. Now, some of the capstone projects that got turned into me had a lot of how. Who cares? Too early. Tell me what it's going to do. That's the most important thing. Okay? The other important thing that a requirements documentation does is it serves as a communication tool. And we've talked about this a little bit before. Do you think an entire design team is going to be located together in the same office? Children of the 21st century. Do you really think they're all going to be together? Absolutely. No, yeah, Skype. Yeah. Good luck with that now. Another outage. Oops, sorry about that. So look, the power team will be here. The communications team will be there. The mobility team will be there, right? And they're all going to be building their own little parts of the big blue widget. Well, you'd like it all to work together when you plug it together, right? And how the heck's that going to happen? You really, if you're going to be singing a song, you better be using the same music, right? And ultimately, the requirement specification is the music that everyone's going to be singing. All parties need to agree to the content of the requirements before development proceeds. We had talked about this a little bit when we talked about the different types of design, the different types of development processes and stuff like that. The farther you get into a design or a development process, making changes, it becomes a lot more what? Expensive or inexpensive?
Expensive.
A lot more expensive, right? If I'm halfway through a project and I go, whoops, it's too big. Let's make it half the size. All of a sudden, that's going to change the design. It's going to become a lot more expensive. If I can get everybody to agree on the requirements at the beginning of the project, okay, if we're all on the same page, if we all agree on it, and then that's what everybody goes forward and does their design based on, I've saved myself an awful lot of cost, an awful lot of changes. Change orders will kill a project just based on expenses. Requirements can actually serve as legal agreements between the designers and the clients. When I've worked on military programs, truly, the requirements were the agreement between us and the customer. So they came to us and said, we're willing to pay an awful lot of money to have you develop one of these. But guess what? When we get it, we're going to be whipping these requirements out and going, oh, so you built this. Let's take a look at it. Ching, 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 ching. And they're going to be working down the list, making sure that it actually does what it's supposed to do. Okay? And then it can be very difficult to create a requirement specification without spending a lot of time in talking about how it's going to do it. But that's where you need to resist, right? As technical professionals, you're going to want to say, I want to just dive in. I just want to start to create it. You really need to hold off on that. You really need to spend a lot of time defining what it's going to do before you go to how it's going to do it. All right, so how do you go about creating one of these design specifications? In your life, people will be showing up and giving you design specifications. And that's great if you're at this location in the company, okay? You would like to get to this location in the company, right? Is that your career objective? Here to here? Sure?
Yes.
Sorry, you don't have a career objective, do you? Well, you should have one, okay? It's up, that's where you want to go. Well, if you're here, guess what? You're not actually doing the design. You're actually creating the requirement specification because that's a lot more powerful. Okay? You can create a lot of requirement specifications. And that's a lot more valuable to the company. So what do? Really 5 different steps to it. First off, you have to define your requirements terminology. Requirements are so important that there's a lot of terms that have sprung up around them. You better be using the same vocabulary as the people who are receiving the requirement specification. Otherwise, you're going to be talking at cross purposes. Next, you have to actually create a process for developing the requirements. So if you don't have a requirement specification, you got to create the requirements. Cool. How are you going to do that? Sit down with a pencil and a piece of paper and start cranking out some requirements? Sounds good if you're a really good writer. Okay? Maybe we need to think through exactly what the process is that you go through to actually nail down some requirements. You have to create engineering requirements. So it sounds like there's different types of requirements. Then their engineering requirements are somehow different from just like generic requirements. And they are. They're very specific types of requirements. So we'll talk about that. Create a complete requirement specification. This is a powerful term. Requirement specification. That's the whole shooting match. I would like you to build a blue widget. I'm going to give you a requirement specification, and it's going to have a bunch of things. It's going to have engineering requirements. It's going to have marketing requirements. It's going to have a bunch of different requirements in it. Okay? It's all the things that go together to make a blue widget. Not just half. Not just the engineering requirements. You can make a great blue widget just based on the engineering requirements, but if you don't have the marketing requirements, nobody would ever buy it, right? Because it was ugly, it was too big, it was too small, whatever the scoop was. It just wasn't designed for the market. And then finally, you have to account for both constraints and standards. What are constraints?
What you can't do.
What you can't. Well, that seems sort of a harsh way to say it. Is there a better way to say that?
Limitations. What you're allowed to do.
Limitations. Okay, so now, and that's still in the same sort of ballpark area, but yeah. So in other words,
More realistic.
realistic. Actually, I like that. I think that's getting pretty close, right? So you don't necessarily have unlimited what? Time, money, environmental concerns, power, for example. You've got a bunch of restrictions that your design is going to have to operate within, correct? Well, you better be aware of what those are before you start cranking out that design. I'll need 100 megawatts for this particular radio receiver. That's fine. But you're not going to be getting it in my house, right? All right, so those are constraints we have to take a look at. All right. So, requirements terminology. So let's take a look at this. By the way, do you guys recognize what this is? It's a Roku. You guys know what it is? You heard about it at least?
No.
So who can tell me what a Roku is?
So it's on your TV, basically.
It does. Now, does it put widgets or does it? I thought it does one thing. I thought this was just a Netflix box. Does it do more than that?
It can put more than that.
Okay. All right. So if anybody doesn't know what a Roku is, by the way, it's a standalone device. If you had a Netflix subscription, among other things, what you could do is you could put a Roku device in your house. It has Wi-Fi capability, so it'll hook into the internet. You would then plug this into your TV, put your TV on auxiliary for the input, and basically you could stream your Netflix off of the internet through the Roku box and into your TV. So if you wanted to watch streaming Netflix, this is the box that you would get. You'd be able to watch it on your TV. You'd be good to go. So effectively it takes video content on the internet, streams it through, and puts it on your TV. That sounds like a pretty cool box? If you didn't have it, it'd be pretty cool on that. Now you can do this other ways. What are other ways that you can do the same functionality? Whip up your laptop. Get a Blu-ray DVD player, right? A lot of DVD players have this functionality with it, built in, stuff like that. You didn't have any of those? Roku's the way to go. I think it's like about $80 or something like that from Amazon, I think. All right, so let's talk about this. Say that it didn't exist. Say that they had come to you and said, listen, I want you to actually create one of these. What would they have to give you to do that? Let's take a look. What's our first one here? Oh, marketing requirements. That seems like a good place to start. I mean, why build something if nobody's going to buy it, right? Or use it, for that matter. So what are marketing requirements? What makes a requirement a marketing requirement?
It's an alternative to something more expensive.
Well, okay. So, but you're right. That's almost an example of a marketing requirement. If I had to define what a marketing requirement, what would make a requirement specifically, it would be hey, that's a marketing requirement as opposed to an engineering requirement or something else.
Saying that's a product.
Appealing. That is actually more like a marketing requirement. Most of the appealing.
Does it mean functionality?
It's what sells it.
You're missing it. Okay.
It does what you want it to do.
It does it, but who? Then who wants it to do?
Customer.
Ah. Ooh, now we're on to something. So who actually, quote, writes a marketing requirement?
Customer need.
Customer need. But who's writing it? Who's actually, in theory, scribbling it out? Where do they come from? Maybe that's a better way.
Marketing team.
What's that?
The research team.
The research team. And where does the research team get them?
From the population.
From the population.
Research.
Another name for the population would be customers. Right, exactly. That's exactly correct. All right, so really marketing requirements are statements that describe customer needs using the language that the customer would use. I need 50 milliamps of power delivered. Yeah, no, that's not, we're not seeing that, are we? What are we going to see? We're going to see things like
Fun and bright.
should be lightweight, right? Is that how you would describe something? Should be easy to use. What would our marketing requirements for our buddy the Roku be? Small, because it's crowded up on my TV, right? What else?
Cost less than a DVD.
There's a price point, right? It's only $1,000. Goodness, come on. You can stream internet stuff. That's cool. What else? What's another marketing requirement for? Look how cool this is. It's got stuff on the back.
Streams Netflix.
So there you go. We're down to a functionality, right? It has to do what I would use it for. Stream Netflix. What else?
Easy to connect.
Easy to connect.
High quality video.
What's this?
Is that
It's a remote. Am I going to be getting off my sofa to go over and change my... No, right? Okay. So it's got to have a remote, right? What else?
Easy to use interface.
Easy to use interface. Exactly. If it's hard, I'm not going to be doing it, right? Okay. What else?
Got a sleek black look.
I love it. I paid $1 zillion for my ultra thin whatever Bob, and I want to match that, right? Blend in with that. That's cool. Anything else? Other marketing requirements for the fantastic Roku box.
Got a catchy name.
You know, that's interesting. As a customer, I don't care. You're right. That's more of a marketing.
consciously care.
Basically, stuff on it.
Like you want to write, I want to
like
write
the
it.
20, so it was like the converter box DVD, blah blah blah. I don't want to buy it. Roku, bam.
Here's an interesting thing. So this has to get its content. To get its content, where does it get its content from?
Internet.
From the internet. Cool. All right. So that means it's going to have to connect to the
Internet.
okay. And I can't have you go off track on this. Come on with me now. So how's it going to do that?
Internet.
See, because this looks suspiciously like an internet. So it looks like
But you said it has Wi-Fi.
it does. So it looks like I can do it.
Both ways.
And is that a good thing?
Both internet.
It's twice as fast.
Okay, so it looks like giving me options is something that I would want as a customer, right? Maybe I want to jack it in, or maybe I want to use Wi-Fi. Okay, well, that's cool. All right. So marketing requirements seem to be part of our, if we want to specify our design for our Roku. What else do we have here? Engineering requirements. Well, we already talked about that. That's fantastic. So what are engineering requirements? Just a cooler form of marketing?
Pretty much. I mean, well,
No power.
Well, so if I had a requirement, how could I tell if it was a marketing requirement or an engineering requirement?
It's technical or not.
Technical. What would make it technical?
If it uses fancy words like volts.
Fancy words. How cool is that? So I guess what you're sort of saying is that engineering requirements we would not expect to be expressed in the terminology of the customer, right? Okay. Lightweight would not necessarily be an engineering requirement, correct? 0.5 pounds might be an engineering requirement. So engineering requirements apply to the technical aspects of the design. Here's the key point. Ideally, each engineering requirement is both measurable and has an associated target value or range, right? So if I'm going to be talking about how much power it's going to draw, I'm not going to say it's going to draw power. What am I going to say?
The exact amount of power.
Right. And am I going to say very specifically the amount of power, or am I going to give it a
Could be either
a
or.
range? Right. Okay. Maybe a max and a min. Whenever you get something like this, you take out the box, you read through it, all and stuff like that. What does it say about the physical environment that it can operate in? What does it always say?
Temperature.
A certain temperature, right? If it gets too hot, is it going to operate? No. And if it gets too cold, is it going to shut down? All right. So, for example, those would be engineering requirements, right? All right, so what else we got here? Performance requirements. What would a performance requirement for? Well, what is a performance requirement?
Like, it can do something.
Performance. Thank you very much.
What it's expected to do.
Gotcha. So performance requirement is like a refined engineering requirement. Okay? What we're really looking at there, it's an engineering requirement that's more limited in scope and really only specifies performance-related parameters. So with our little Roku box, can you think of a performance requirement?
High quality video.
Resolution.
Okay, now remember, high quality video, that's good, but you know, your eyesight isn't that good, but mine is really good, all right? So what's high quality to you is probably not good to me. So how are we really going to specify high quality video?
Resolution.
Resolution, right? Now,
HDMI.
you know, there's an HDMI port there, right? Now, because you guys are all technical professional, what are the different flavors of HDMI that you can have? 10 amp, now it's also what, 720? 720?
It says a 480.
Seems like we need to be a little clear there, right? What am I actually buying here? Is it a 720 or is it a 1080? And is it an I or is it a P? Or is it both? Right? Do those seem like those might be possible performance requirements? All right, that's good. What else we got here? Requirement specification. Now, once again, the requirement specification is the whole shooting match. It's marketing requirements plus engineering requirements plus performance requirements. Grab them all together. They all go into the requirement specification. Okay? And really, that's what you want. You want it to all come together because ultimately, if you're doing the design, that's what you need to know is what's going on. I think we got a couple more here. A functional requirement. If the system is more complex than a little Roku box, okay? If it's got a lot of detailed subsystems, what you're going to bump into is functional requirements. Functional requirements, they're going to have the goes in and the goes outs, the inputs and the outputs, okay? And also a functional description of what goes on in that subsection. And it's just because whatever you're working on is so big and so complex that if you just try to come up with a generic set of requirements, nobody will be able to work their way through it. So if you have something that has a lot of detailed functionality, you'll have individual functional requirements. And finally, we get down to something called technical specifications. And unfortunately, this often gets mentioned in the same breath as this, and it really shouldn't. Because technical specifications tell you exactly what the product does, and it actually also tells you oftentimes how it does it. You write the technical specification after you've created the product. Right? So your user guide or what you get when you purchase the product, it contains a technical specification. And the reason it contains it is because somebody wrote it when they physically had one in their hand. Okay? They actually had it, they could pick it apart, and they wrote their technical specification from that. It would be fantastic if you had a technical specification before you designed the product. Because then you could just copy it, and that'd be fantastic. But it doesn't work out that way. Alrighty. So, how do we go about developing requirements? So really, if you're going to develop requirements, somebody needs to tell you what the requirements are. And if you were at Hogwarts and if you were Harry Potter, it'd be a lot easier than it is in real life. So truly, you have to go and have somebody come and tell you what the thing needs to do. So you've got basically three sources. So the first source, of course, has to be the end user, has to be the customer, right? They're going to give you what type of requirements? Engineering requirements? Marketing requirements, right? And they're going to express it in their language. So you're not going to have a ton of detail here, but you're going to have a great functional understanding of what the thing actually has to do. I will buy your product if it does this. Well, you better do it then, right? All right, so another source is basically the environment. And so that's external constraints, external standards. Remember, this is starting to limit the type of design that you're going to be able to produce. Only so much power, only so much size, only so much as far as the operating constraints, et cetera, et cetera. And where else we got? The technical community. Listen, whatever you're getting ready to design has probably been designed before, or something similar has been designed before. Okay? It would be the height of arrogance for you to assume that you're creating something that has never seen the light of day before. Some portion of it, some aspect of it has already been done. It behooves you to go out and find out what's been done before. Okay? Hopefully whatever you're doing is going to be better than what they did. But you should figure out what they did as a starting point and move on from there. Especially if you're talking about standards or something like that. All right. Engineering requirements. This is where things start to get very interesting. Okay, so we talk about requirement specification being the big shebang. Okay? Everything's in there. Marketing requirements, engineering requirements. Engineering requirements. So what is an engineering requirement? It's a short statement that addresses a technical facet of the design. We're not talking paragraphs here. Okay? I will use 50 milliwatts. It doesn't take up an awful lot of space. Okay? They're designed to be concise. And 50 watts of power. All right, so you get sort of an example of that. So, if we're talking about engineering requirements, we should probably talk about the properties of engineering requirements. And there's 4 of them that we need to keep our eyes open on. So let's see, the first one is, an engineering requirement has to be abstract. We're going back, you'll hear this over and over again. Don't tell me how it's going to do what it's going to do. Tell me what it's supposed to do. Okay? Don't tell me how you're going to make it small. Tell me that it has to be small. Tell me the size. When I worked on aircraft, the key concept on an aircraft, weight kills was the rule on an aircraft. Everything that weighs means that you can't fly as far. You'll use up more gas to get to where you're going. So the concept was, this is the space you have to put the device, the radio or the radar or what have you. It's going to fit in this space. Now go make it happen, no matter how hard that is. All right? So it has to be abstract. Don't knuckle down too early. What else do we have? It has to be unambiguous. Okay? You can't say it will be fixed in a spot and it must get to 60 miles an hour in under half a second. Okay? Basically, all the requirements, when you take them all together, they all have to be able to live together. Don't tell me it's going to be blue and then tell me it's got to be red. Okay? You have to be very, very consistent. And you go, well, of course they're going to be consistent. No, there's not going to be an issue there. Trust me. If you get a big requirement specification, and if you get a requirement specification that's being made by multiple people, you're going to have huge issues that it's not going to be consistent. Okay? So the review process for requirement specification, it consists of people going through it, looking for inconsistencies. Looking for you telling me to do this and this at the same time, and clearly I can't do it. That's a huge issue. All right, what else does an engineering requirement have to do? It has to be traceable. This is another huge one. Technical professionals go, hey, I know what the thing should do. I'll put a requirement in for that. Because I know, because I'm really smart, that this is something that the product should do. Well, okay. But to do that thing is going to cost me $1 million. I don't disagree, that's probably a cool thing. But why am I doing it? I'm doing it just because you thought it was a good thing to do? Look, if I'm doing anything on my Blue widget, I better be able to trace it back to a marketing requirement. It had better be something I have to do to meet a customer need, right? If I'm doing it just because it's cool, I should have a gas plasma interface because that's just what everybody's doing these days. No. Okay? It has to trace back to a marketing requirement. If it doesn't, you're wasting my time and you're wasting my money. Okay? And this becomes huge, especially as a product goes on, especially as it gets into multiple revs. And because those engineering requirements can sort of sneak in there without a clear source for them. Finally, it has to be verifiable. Okay, this is the key thing. You don't see it so much in consumer products do have this, but it's a little bit more harsh. It shows up at Best Buy and nobody buys it. That's called verifiable. If you're going to a customer who actually contracted you to build a very specific product, when you show up and you have the product and you go to them and you say, I'm done, they don't say, fabulous, here's a check, I'm done. Instead they say, oh, you think you are. Let's find out if you are. And they have a whole group of people who will sit down and who will step through each and every requirement saying, does it meet this requirement? Right? They probably have a test lab. Verizon has a lab dedicated to testing communication gear. So Cisco or Juniper shows up and says, we've got the best router in the world. It does all this great stuff. And Verizon says, show me. and they spend the next 2, 3, 4 months in the lab going through each one of the manufacturer's claims, making sure that it actually does it. So, what was it? Ronald Reagan said, trust but verify, I think is the gist of it. So, marketing claims are great, but nobody ever believes them. All right. So let's take a look at an example requirement. Remember, we determined that engineering requirements have to be, repeat after me, abstract, unambiguous, traceable, and verifiable, right? Rock and roll. All right, so here's our example requirement. All right, the robot must have an average forward speed of ½ foot per second, a top speed of at least 1 foot per second, and the ability to accelerate from standstill to the average speed in under 1 second. So my first question to you is this abstract? Is this telling us what it must do, or is it telling us how it must do it? So it sounds like it is abstract. Would you agree with me? All right, so we're one down. Is it unambiguous? Do we have any conflict in here? Top speed of 1 foot per second, unless it's really going 60 miles an hour, something like that. So is it unambiguous?
Nope. No.
Somebody said no. Talk to me.
Ooh, what do you want to know how big?
Interesting question. Based on the words that are here, is there any conflict?
No.
Okay, so we can live with that. All right, so it sounds like it's unambiguous. Traceable, we don't have the marketing requirements, so we really won't be able to determine that. Verifiable, would we be able to verify this? Is this something you could test? Pretty easy, right? Which actually brings up an interesting point. Oftentimes when you're putting together a design, you're thinking about meeting the requirements. There's a whole other side to design that says, listen, I understand that the customer that I deliver this to is going to want to verify that it can do this. So you build into your design the ability to test it. Test ports, test displays. So once upon a time I got on an airplane with a guy that I was traveling with, and it turns out that he, in a past life, had worked on the software development team that had developed the software that was used in the Airphone. You know Airphones. Remember back in the day, it was a phone that was in the back of the headset in front of you where you could, all that sort of stuff. He said, cool, watch this. And he just took the handset and did some stuff, and he turned it into German, first off, for the entire plane. He said, I put it in test mode, watch this. And he kept doing that. I was like, okay, listen. And this is all before 9/11. I said, please, just put it back into the right mode and put it back. I don't need to have them coming up to me and saying, our phone system seems to be in German. Has somebody changed it? Has somebody modified it? All right. So let's go on here. Let's see what the story is. Okay, let's take a look at another robot requirement. Okay, this one says the robot must deploy IR sensors to sense its external environment and to navigate autonomously with a battery life of 1 hour. I seem to recall there's some battery lovers in the room, so I'm hoping that this is appealing. All right, so we're good with that. So is it abstract? Does it tell us what to do, or is it telling us how to do it? How, right? So what kind of sensors does it have? Why not sonar? Why not sound sensors? Don't know. Interesting question, right? But they're telling us how to do it. Don't do that. We will create a design, and maybe we do use IR sensors, but don't tell me that in the requirements.
But what if they're like completely against sonar and they really want you to use IR?
Well, why not use visual?
Or maybe they have their heart set on IR.
But that's well. Here's the interesting thing. They should never tell us IR. Tell us the reason why we should use IR, right? Maybe it's an acoustically noisy environment. Cool. Then make that one of the requirements. Must operate in an acoustically noisy environment, right? And just tell us that, and then we're good to go. We may end up at IR, but there also may be like laser range finding technology or something. A lot of different ways to do it. Remember, we don't want to constrain the design. We want to make sure that we've got a lot of as much flexibility in the design as possible, and yet at the same point in time, we want the requirements to tell us everything that's going on. Okay? So good point. Is it unambiguous? Careful. What does autonomous mean? What does autonomous mean? Automatic, does sort of. It's a little bit more than that, though, isn't it? It's like by itself, right? Seems like we should sort of nail that down a little bit more, right? What do you mean by itself? Okay? And traceability we still can't figure out because we don't have the marketing requirement. This isn't quite making it, is it? Let's try again. Okay, all right, here we go. One more shot. The robot must navigate autonomously with the aid of only landmarks in the specified environment for a period of at least 1 hour. Oh, wait, that was one other thing. So, battery life of 1 hour. Great. How long does the robot have to last? How long does the robot have to operate? Don't know. It died a half an hour ago, but that battery still got some juice in it, right? That wasn't terribly good. All right, so on this one, autonomously, all right, so let's take a look. Is it abstract? Are they telling us how to do it? Now, they told us once again that it's got to be autonomous. But did they tell us how we have to sense where these landmarks are? No. All right, so that seems pretty good. So it looks like abstract's good. Is it unambiguous? Yeah, we got that battery thing out of there. Okay, they told us to operate for at least an hour. Okay, now that's cool. We know what that means, right? Let's not mess around with the battery or anything like that, but let's at least tell us that. All right. So we're going to go through this fairly quickly, but here's the scoop. So requirements come in a bunch of different flavors, okay? And they relate to different things, specifically engineering requirements do. This is performance and functionality, okay, which is a huge area. Whatever you're designing, whatever you're building, I want it to do something. In this particular case, what is it? Should be able to detect 90% of all the human faces in an image. Okay? Should be able to measure the location of a part to within a little bit of a plus or minus 1 millimeter and stuff like that. Fantastic. Okay? So these are requirements. Performance measures are critical measures to impact the acceptance of the product by the end user. So this is really specifically what I want your product to do. That's when performance issues come into it. They describe the ability of the device to perform its intended function. Accuracy specifies acceptable levels of allowable error. So once again, we get down to an interesting point here. You really don't want to be super specific on this, right? Because nothing in this world is super specific. And anything, any machine or part like that is going to have tolerances, right? And you'll get in tolerance and out of tolerance and stuff like that. So really, in an engineering requirement, what you want to discover is the max and the min, right? You know, how close do I have to get? And then you want to work that into the requirement. Reliability and availability. The system will have a reliability of 95% in 5 years. What does that actually mean? It's going to start out at like 50%. Woo! In 5 years, it's going to be up to 95%? It's actually, I believe the intention on that is that 95% of the systems will be operating correctly in 5 years. So your failure rate over 5 years is only going to be about 5%. I think that one could actually be worded a little bit better, but whatever. Mean time of failure of 10 to 6 hours and stuff like that. These requirements are talking about the expected period of time that the system's going to operate correctly. Once again, this is a critical thing. Depending on how expensive the item that you're designing is, you would expect to have more and more of these. If it's a cheap, throwaway consumer item, whatever, right? Also, if there's health and safety, you know, if you're designing a robot to work in a factory, and they prefer that you don't crush too many workers, you're going to see a lot more of these type of requirements, right? Must shut down if Skynet takes over. All right. Energy requirements. You will always, always, always have energy requirements. Energy requirements, generally what you discover on energy requirements is that they're specified in terms of a max energy, a minimum amount of energy, and then perhaps an average usage. Okay, those are really the three big ones when it comes to energy requirements. Environmental, although I would like to say that this has to do with beautiful green things, this really generally deals with the environment in which whatever you're designing is going to operate. Okay? It's going to be someplace. It's going to be in the Arctic Circle. It's going to be going down the Amazon River. It's going to be in a computer server room. Doesn't matter. It's going to be someplace. And if it's going to be there, what are the requirements or what are the constraints? Humidity is a huge one because that can certainly impact things, right? Temperature is a huge one, et cetera, et cetera, et cetera. An interesting point, and something that I think is only starting to come on, how is your product going to work if power is lost? And the reason I bring that up is because over in Japan, before the whole tsunami thing, they had a brownout. You guys know what a brownout is, right? Mm-hmm. So you don't really lose power, right? You almost sort of lose power, right? Everything dims and then comes back, right? And those are annoying, but they happen and you move on. Well, they had a really big brownout. And unfortunately, they had it, I think, actually in the northern part of Japan. And that, of course, is where all the chip factories are. And it happened so quickly their backup systems didn't turn on. And also because they didn't lose power, the backup systems didn't turn on, right? Because they're designed to kick in when you've lost power. Well, there was a brownout, so they didn't kick in. But when you're doing X-ray lithography on those, silicon discs and stuff like that, having a wiggle in your power like that messed it all up. All those wafers they were working on at that moment in time were trashed. So what happened was memory prices for like the next month went through the roof because the supply was killed. And so imagine somebody had to go through one of those huge factories just throwing away silicon discs because they had a brownout occurring. Which is interesting. I'll bet you next time they buy chip making equipment, there's going to be a requirement in there that says, hey, if there's a brownout, stop. Don't do something, right? Because it's going to be way too expensive if you burn out one of those discs. All right. Software and computing, we all know about this sort of stuff because we do it all the time. Basically, software requirements generally break down into two groups. One's called functional. It says, hey, this is what the software needs to do. The other one is non-functional. It says, listen, this is what the software, this is the type of environment that the software has to be in. Developing the requirement specification. All right, so this is the stuff. This is where we get down to actually, if you were writing a requirement specification, here's the things that you need to do. What do you have to do? You have to make sure that they're normalized. It basically means that you don't have overlapping. You don't have multiple requirements talking about the same thing. Otherwise, your users are going to get sort of confused about what you're talking about. It has to be a complete set. Don't tell me how to build half a car, because that's not really going to do me or the people who get the car any good. Hey, nice half car you got there. It has to be consistent. Okay, once again, this is the same thing. You can't tell me to do one thing and then 2 requirements later tell me to do the opposite. It has to be bounded, right? So you've got to give me some scope as far as where you want that particular requirement to fit. Granular, you got to give me enough detail. But at the same point in time, don't narrow my design options, right? So not too high, not too low, probably somewhere in the middle is the right way to do it. And understand that requirements always have to be modifiable. It would be fabulous if you could create a requirement specification that was perfect. Woohoo! Unfortunately, it'd probably be the very first perfect thing you'd ever done in your life, right? Requirement specifications are never perfect right off the bat. They are always constantly changing. And what happens is they put them together, really smart people review them, tons of changes get made, they get distributed to the design teams. And you know what the design teams do? They ask questions. They come back and go, hey, requirement number 473 seems to be, did you mean this or this or this? And they make a decision. They change or reword the requirement, and then they distribute a new copy of the requirements to everybody. And that becomes the Bible that everybody really stops. All right. How we doing? Ooh, all right, we're pretty much on track. Shall we talk about your capstone project? Seem like a reasonable sort of thing? I mean, it's your capstone project. So where are we on the capstone project? You've picked a project, right? How do you feel about your project now? Still comfortable with it? A little iffy? Some of you should be a little iffy. Okay? But it's cool because you can change your project. We're not holding to that. What's the next step? You need to come up with a problem statement for your capstone. Are you doing a problem statement for your multi-part team project? Please not. Please not. Okay, thank you. Excellent. Well, since you're doing it for that, you may as well do it for your capstone. That sound like a fair deal? Okay, so what I want you to do is I want you to write a problem statement for the capstone project that you've selected. Here's the cool thing. If you don't like your capstone, change it. I don't care. Okay, it's your capstone. If since you turned in your project selection, you've changed your mind on, man, that doesn't turn me on, I heard about something better, I've decided to do whatever, cool. Not a problem whatsoever. This does not have to be the same capstone that you turned in last time. I don't care. I just want you to turn this in. Okay? What does your project statement need to contain? It needs to have a need, it needs to have an objective, it needs to have background, it needs to have marketing requirements. And it's due on Thursday. You already spent 8 hours over the weekend working on the one for your multi-part team. This is yours. You're already intimate with this capstone project because you took so much time carefully selecting it. This should just flow out of you. Question?
What happens if you're already working in your group on your capstone project?
Group?
Yes, group.
You work in whatever group you want, but you get individually graded on this. So
But what happens, it's a group project though, so how do you say that?
well, but you already turned in an individual capstone selection, correct?
And I've already changed it, so.
Which is fine. Then what
So
means?
that's almost something.
What that means is that although you're working as part of a group, which is cool, no problem, you ultimately own that capstone selection, correct? I mean, it's your capstone project. You may or may not be working in a group. That's fine.
Well, it's already been decided that we're working in a group, so how do we handle that?
I want individually from you this. You should be able to give me a problem statement for the capstone project that you'll be working on. The fact that you're working on a group is interesting but immaterial.
Okay.
Is that clear?
So there's gonna be 4 of the same thing then?
Yeah, but I want you to be writing yours and them to be writing theirs, right? What would be fascinating if we laid all 4 of those out by each and saw if it was the same thing, right? What's it, the 5 blind men and the elephant?
Yeah.
All right.
Can you define need,
Yes.
like what I needed to do or what?
Well, let's take a look. That's a great question. Let's take a peek, shall we? So what does it mean? It's identifies the needs of the project. Okay. So it also comes up with interesting marketing requirements for a capstone project. What the heck's up with that? So look, you're doing a capstone project, right? You're producing something. It has to be for somebody. There has to be a reason that you're doing this. Okay? Invent your customer. Who would use what you're going to produce? What problem is it going to solve? It best be solving some sort of problem. Huh? So what's the need for your project? It better not be just a kit project. All right? What problem does your project solve? What issue does it address? Is that clear? So my 10-year-old just finally got around to unwrapping an electronics kit that I gave him. Actually, it's Christmas. But it was pretty cool because his eyes lit up. You know, he's been doing Legos. You know Legos, you know, and all that sort of stuff like that. He actually does a very good job of it. He gets the kit, sees the little book, puts it together. Proof he's got his Star Wars X-Wing fighter with him. Last night he was sat down, he took a look at it, and it's interesting. Electronics kits these days, there's no wires. It's all snap-together stuff. So a wire is actually a snap-together thing, and they've got transistors as a little plug-in module, and they've got sound chips as a little plug-in module and stuff like that. And it was like one of those revelation moments when he started to understand how this thing all came together. I'm thinking, oh God, we got ourselves an engineer here, right? But it's all sorts of fascinating. There's like 305 different projects he can build with his brand new electronics kit. He can make an AM radio. So don't you be having an AM radio as your capstone project, right? I got 305 projects my son can do with his brand new electronics kit. If I see any of those show up in a capstone, we need to be having a talk, okay? He made a circuit that if you push the button, the light came on last night. Once again, not a good capstone project, okay? 305 of these, okay? Whatever you're doing should be better than what comes in my 10-year-old's electronics kit that he can snap together in probably under 5 minutes.
I'm thinking like your kid's electronics set will make an AM radio, but will it make a good AM radio? Probably not.
It
So,
says Bose on it. I don't know. Is that it's not clear.
Price.
I mean, it's a high-end kit. I mean, goodness gracious. So yes. So hopefully we're all on the same page there. Are there any questions? This is up on Dashboard. If anybody wants to know about it, so it's all good to go there.
Blackboard.
What did I say? Dashboard?
Dashboard.
See, I've seen about putting the AM radio into the dashboard. Is that hard? I'm thinking, wow, that's the way. But yes, you're exactly correct. Blackboard. All right. So that'll be exciting. So on Thursday morning, I will be up here, and then you can come in and you can turn in your problem statement. And I'm assuming that everybody will be turning in a problem statement on Thursday. Does that seems like a fairly, because I've been clear. I've expressed myself. I put it on the big board. I put it on the blackboard. I mean, I'm thinking there's no possible way anybody in the class could have misinterpreted what I said. Is that a reasonable understanding? Right. Because I'm not going to single out anybody, but I'm just going to say. Where are we? Oh, hey! Doesn't this guy look nice? Isn't he well dressed? got a sport coat on, he's got a fancy shirt. You know, that's a fancy shirt, too, because he's like one of those Wall Street guys. That's probably like, what, $250 shirt, something like that.
Look nice in prison.
He's got a nice haircut and stuff like that. They're probably fancy pants, and I bet he's got cufflinks. You just know he's got cufflinks on. And then these are all law enforcement officials. And he seems to be going with them against his will because he's being arrested. So clearly he made an ethical bad decision. We would prefer that you, perhaps dressed as nicely, or maybe not dressed as nicely, would not be let off by policemen at any point in time during your, how long is it, career? 45-year career. This is something you want to avoid.
I thought you were saying I should always be dressed nicely.
You should always be dressed nicely.
I'm really arrested.
Because you never know when you're going to be arrested. It's like what? Clean underwear because you never know when you're going to be in an accident type of deal. Dress nicely because you never know when you're going to be. And don't think that not dressing nicely is going to prevent you from being arrested. I've seen cops. Apparently they'll take you at any time. So this gentleman, Ralph, to his friends, worked for Bear Stearns. So what was his ethical lapse? What did he do wrong that the police showed up and took him from his Manhattan apartment? Well, here's what Ralph did. So Ralph was in charge of a mutual fund where people give money to Bear Stearns, which by the way no longer exists, gives money to Bear Stearns, and Ralph would take it and he would invest it for them. And if it did well, they would make more money, and if it did not so well, they'd lose some money, but that was his job. Now, Ralph happened to invest in properties or items, investable items, that had to do with real estate, which we all know sort of tanked a little while ago. And what happened was the funds that Ralph was investing in started to go south at the beginning of the global recession. And it's Ralph's job to stay on top of this. And he saw it starting to tip off the cliff. But Ralph's other job is to sell his mutual fund, to get more people to invest in his fund. So Ralph was getting on phone calls and saying, yeah, there's a bump in the market, but I really think this is going to take off. You know, this is just a temporary thing. Real estate's the gold of the future. You need to continue to give me your money, and I will invest it in my fund, because I think the future's very bright. At the same time, Ralph's sending internal emails to his pals going, oh my God, it's the end of the world. We really got to stop doing this. But he didn't stop doing that. He kept taking people's money, even as everything started to slide downhill. So he had this huge trail of emails in which he's talking internally going, this is a really bad idea. And yet on phone calls and in discussions with investors, he was like, you got to get in now, because I've got limited space. I've got a couple spots left, but if you give me your money now, I can get you in, right? So he was telling his customers one thing, he was talking internally differently, and now Ralph has an opportunity to spend about 15 years in jail for violating SEC rules about how you actually do this stuff. He made poor ethical decisions. Did he rob a bank?
Yeah.
Did he shoot somebody? Well, we don't know, but let's assume not. Did he take somebody's car? Essentially. Is he going to jail? Their car, their house, their savings, exactly right. And yet still you go to jail for that stuff. Go figure. All right. So we're in the process of trying to come up with an ethical framework that will hopefully keep you guys out of jail. What have we done so far? Well, we said, look, you have to recognize that it's an ethical issue. You got to understand it's not as simple as choosing lunch, but this is one of those things that's going to require you to think about it a little bit. You have to get the facts. As with everything in life, you can't make a decision if you don't have all the facts. What are we going to do today? Well, look, once you have all the facts, you have to take a look at it and go, look, there's multiple decisions I can make. It would be great if your mom would show up and say, hey, you know, we've talked about this situation before. Here's what you need to do, right? That would take all the burden off your shoulders. If you had a parent show up and tell you what to do. It doesn't happen that way. So you're going to have to evaluate it. Remember we talked about all these before? So when you're evaluating your options are, you need to sort of put it in context. Question, which option will produce the most good and do the least harm? It's going to kill 10 people or it's going to kill 100 people? Which way should you go? Well, I don't know who are those 10 people. I mean, are they good looking?
Those are real fun.
Which option best respects the rights of all who have a stake? So we talked about this, right? You know, do you view every person as having rights? And if so, do you have, when you make your decision, are you going to be violating their rights? Interesting question. Which option treats people equally or proportionally? Are you going to tall people have more rights than short people? Does that sound fair? When it comes to ceiling fans, it's sort of, okay. which option best serves the community as a whole, not just some members? People who live in North Tampa have more rights to cheap water than people who live in South Tampa. Does that sound fair? Depends on where you live, right? All right, and then finally, which option leads me to act as the sort of person that I want to be? And hopefully it's a virtuous person. All right. If I take this action, am I going to feel good about myself? Would my mom be proud of me? All right. Fantastic. Let's put it into action, shall we? What's interesting, I'm going to give you 3 scenarios. I've been in all 3 of these scenarios. Let's see how you guys handle them. All right, so receiving a holiday gift, okay? You're a technical professional, you're working for a company, you do lots of designs. Because you do lots of designs, you have lots of vendors. Vendors are always knocking on your door and saying, hey, we've got the greatest whatever. You're like, whatever, show me some specs, okay? Anyway, Christmas swings around, suppliers send you a box of really expensive stuff. What would be an expensive basket? What would be in that basket?
Gold.
Gold, that's fantastic. Yeah, probably not, but anyway. What kind of food items? What food items would capture your attention? Godiva chocolates, fantastic. What else? Little Jack?
Oh, yeah. Gentleman's Jack.
Maybe some Cristal, perhaps? You know, just it's a party basket. Woohoo! All right. And it's got a car. We hope you and your family enjoy the goodies. All right, so let's say the total value of this basket is like maybe $500-600. Huh? Diggity, you got the best job in the whole wide world. What do you do with the basket? Now remember, here's a key point, it came to your house. Whoever you're working for said, yeah, you got it. And you got it from a supplier. Why do you think the supplier sent it to you? Because you're a reputable person? Obviously. What are they trying to do?
Bribe you.
Get on your good graces, right?
In a nice way. Yeah.
What do you think? Is that fair to the other suppliers?
That won't do it.
You don't know.
That'll do it. Woo, you're in. So your price is $500 or $600. Okay, cool. All right.
You don't let it.
Maybe 400 would have done it. Maybe okay.
You take it. You don't let it affect your decision. I agree.
How could it not? Those are Godiva chocolates. You've been thinking about those all year.
Because you look at the business plan, not what they give you, like not what the
Well,
gifts they give you.
he certainly made us some tough stuff. Because he's not going to let that $600 delicious basket that your wife will constantly be going, that was a great basket. Can you get more of those baskets? He's not going to let that affect him at all.
I don't play.
They already gave it to you. They did give it to you with no strings attached, apparently, right?
Suckers.
Suckers, take them. You think so? Do you really think this would influence your decision? You're going to remember this, right? I mean, what if they showed up with a car? Boom. Hey, you know, Lexus has a new car. Now you have one.
Now we have to consider.
Isn't this just what all those college athletes? What's the school that's in big? Miami.
Ohio.
Is it Miami? Ohio.
Ohio State.
Why are they in trouble? I mean, it has nothing to do with their football playing, is it?
It's against the rules.
They're just gifts. Why is it against the
It
rules?
should be allowed to get money though. That's
Yeah.
It's illegal.
Why?
Because that's what the NCAA laid out.
Well, they're wrong, right?
Yeah.
Okay.
Yeah.
Right.
Yeah, they're wrong.
Because they work really hard.
Because it's not
They're
fair
really
for schools
hard.
like USF who don't have that much money.
Oh. So they didn't
Yeah. All right. All right. The
You
last
see
one.
clearly now.
Let's go on here. Sales expense. A purchasing manager for a large company agrees to give you an order. They're first. Congratulations. They've never ordered anything from you. Finally, they've decided that your product's the one they're going to go with. But he expects you to agree to make a $200 donation to his favorite charity, a local youth sports team. That has nothing to do with the quality of your product. The beauty of your design has nothing to do with it whatsoever. Oh, he'll buy from you. But you got to do this other thing. I'm having troubles with my wife. I'll buy your product if you kill her. Would you do that? I mean, it's sort of like making a
If you
donation.
kill your wife and donate to a charity.
Do you see a movie in the same place? What do you? I mean, oh, sure. This is where it starts. What else is he gonna? You know, actually, he could have said, "I'll buy from you. How about you give me $200? My company will buy from you, but you got to give me some cash."
It's like kickback.
It
It's
is.
illegal anyway.
Well, it is sort of. It's.
You gotta word it better.
You know what's interesting is not quite. a kickback, but it is sort of, it's a virtual kickback almost, right? Because he's not actually saying you have to, he's expecting you. Right? What do you think, guys? Should you take the order?
Why don't you just wait?
How much is the commission?
Commission's
Like-
like-
Listen, the commission's huge!
How important is this order?
Listen, every order, especially like in a down economy, everyone's huge. How's your boss going to feel when you come back with this order from somebody who's never bought from you before? You're going to be the man, or woman, as the case may be, right? He's going to be very proud of you. Your career is going to go places.
Can't you look at the bright side? It's a charity for a youth sport team. I mean,
Well, so it's okay. What's wrong with that? Hey, hang on. What's wrong with that? There's no downside to that, right? You're on tricky ground here, aren't you? Yeah, he's talking about you doing that. You know, what's it going to take to get his next order? I mean, because you've already started going down that slippery slope, right? Are you going to be able to stop going down the slope, or are you going to pick up speed?
So this is what you do. You turn them in for private
and take his job.
and then say if you don't, you'll be without the $200 donation. I'll turn you in.
I've recorded this message or this conversation.
And when you go to the next company and they say, hey, you're the one who busted the last guy who put an order from
You
you.
say, well, don't try to bribe me.
Yeah.
Oh, yes.
Okay. That would be the shortest customer interaction career on the record. All right. You guys are sort of mixing it up here, man. I don't see any consistency here. You've got to take a look at what are your options here. We talked about options. What are your options?
Yes or no?
You can just document.
Yes or no, and you are truly a technical professional. There's always more than yes and no. Could you say, yes, I'll make the donation and not make it?
That's just unethical.
We're already unethical because we're taking the order, right? So is that more? Is it worse to be more unethical? Is it like double unethical? So don't make the decision yourself. Push it off on somebody else. Go back to your boss and say, I've got this tricky situation, boss. What should I do? You should kill his wife because we really need the order. Okay. Really? You tell the judge that. My boss told me to do it. That's worked well historically. I can't see the downside of that. All right.
Why don't you give them a $200 discount off the whole order?
Charge him more, $200 more. So it makes up for the donation.
Oh, yeah, that's right.
You just give them a discount.
Irv would definitely do that.
Your Honor, it's okay. Because here's what I did. I juiced him on the order, see? Okay. All right. One more, guys. I don't know if we're really... I'm not sure. You guys...
He's not going to hire
So here's an interesting thing.
We're off to graduate and apply.
This reminds me of something. So a few years ago, I was responsible for selling a line of video surveillance system. So the company I was working for, we would design the system, we would install the video surveillance system. And I remember talking with the owner of a Dunkin' Donut. And I said, this is a great system because we're going to point, we can point like 3 high-resolution cameras at your front door. So when the bad guy comes in or when he's leaving, we're going to be able to tell his full facial features. We're going to tell how tall he is. And the guy took me aside and he said, that's great, fantastic. He said, that's not where I want to have the cameras facing though. He said, I want the cameras on my staff. He said, because I'm getting robbed every day by the people who work for me. And he said, but the front door? He said, I don't care about the front door. I was like, oh, okay. And now I understand where his staff comes from. Okay. Taking the $200. All right, one more. Let's see if we can bring it together. We're looking for options, right? Here we go. So a customer executive from your Southeast Asia is going to visit your headquarters facility and meet with your executive team. Fantastic. That's a big order coming your way. Your independent Southeastern Asian agent requests that you reimburse the customer for his expenses, including expenses that could violate your company's policies. The agent will reimburse you. So let's stay with this one. So a guy's coming over to visit you to meet with your senior executives. That's good. He'll be spending money. What will he be spending money on? Plane ticket? Hotel?
Massage parlor.
Food?
Women.
Yes. Yep.
And things that violate your company's policies. Traditionally, that means strip club. Okay, just to be real clear about that. That traditionally, that's what we're talking about.
Yeah.
Okay?
It says could, but
It could be anything, but whatever it is, it violates your company's policies, right? Now, here's what he's asking you to do. He's asking you to take care of the customer's expenses. But it's okay because your agent is going to pay you back. So he'll pay the company back. So effectively, the company's paying nothing for this, right? They're paying for it, but they get reimbursed. So what do you do?
What's even?
He's on his own.
figure out if they
This is just the deck that we've been done. So what he wants you to do is pay all of this guy's expenses, all of this guy's expenses, and he'll pay you back for it. What do you do?
It says
Oh,
could
finally,
violate.
he's
It doesn't
the one.
necessarily violate. It's figure that out.
Let's just say it violates your company's code.
I have reimbursed for things that don't, but like, for the expenses that do violate policy, you can't make that kind of.
Dude, he's a customer. He's going to meet with your senior executives. He could place an order.
Yeah.
And you're going to juice him for the $1,200 that he dropped at Disco Go-Go or wherever the heck he went to. Well, they
Take care of that.
Yeah, but it makes you look desperate.
I'm not gonna compromise the company for one person.
Now remember, where's he from?
Huh?
Where's this guy coming from? A different culture, right? So your crazy little, oh, we don't pay for that, is very weird, because he's from a different culture. And maybe in that culture they do pay. Don't know.
Educated.
Would that be a slide slow presentation? The ABC Corporation has a series of policies that are designed to respect all genders and
There you go.
stuff we're not going to pay for. So what are you going to do, guys? You going to pay him? What are your options here?
You lay it out to the agent. You say, this is what we can pay. This is our policy. And that's all we can do. If you want to reimburse him for his fund
He's
time.
going to place potentially an order with you worth $50 million.
So that changes.
Ah!
You see, this is like breaking lives. You can't do this to us.
You talk to your company. Say,
I'm saying this happens all the time,
Or
man.
you talk to your boss. You say, listen, this might violate policy, but we know we're after else time. Let me go through the company's hierarchy and see if they'll allow it.
Why don't you just get your wallet out?
Here's a gun.
Why don't you just? I do, but that's. Why don't you just pay for it out of your wallet? Wouldn't that just solve this problem?
Well, if you go to your boss and say, listen, if we give him $1,200 to go to the strip club, he'll buy $50 million worth of products, I bet you they'll go, give him the damn money.
It violates your company's
Well, that's what
policies.
you go to your bank
Your
and
policies are what you put in place to show respect to your shareholders. What's that?
Just change your company's policy.
Change the policies. It's okay to shoot the wife. That's fine. All right, we're almost done here. What did we cover today? We talked about the creating design spec. We talked about requirements terminology. We now know what engineering requirements are. You have a homework. Write a problem statement for your capstone project. And we tried to build an ethics framework. Once again, I'm deeply concerned about whether or not we're successful. Next time, more requirements, and we'll keep on building that ethical framework. Have a great time, and we'll see you on Thursday.